Turn left in 200 feet. Your destination is on the right. How many times have you heard that? We hear these phrases every single day. We rely on this invisible system, the global positioning system, to tell us exactly where we are on this giant spinning rock.
I mean, it really does feel like magic, right? You just pull out your phone and boom, this invisible connection to space knows exactly where you're standing. Well, today, we're going to pull back the curtain on the incredible science that makes it all happen.
And trust me, what's happening behind the scenes is way, way cooler than magic. It's this incredible symphony of physics, engineering, and just mind-bending precision. So let's dive in. We got to start at the very beginning.
All right, so the whole system starts way, way up there, in space, with a fleet of what I kind of like to call our cosmic guides. 31, that's the magic number. Right now, there are 31 active GPS satellites zipping around our planet, and they're the absolute backbone of this entire global system. And look, their placement isn't random at all. It's super strategic. They're positioned in 6 different orbital planes. And what that means for you is that no matter where you are, I mean, middle of the ocean, downtown Tokyo, wherever, your phone can almost always see at least 4 of them. And that, right there, is the key to having constant global coverage. Now, these things aren't just simple transmitters floating around. Nope. Every single one of these satellites is carrying an unbelievably precise atomic clock. We're talking accuracy down to the nanosecond. And that level of precision, it's not just a nice to have. It's absolutely non-negotiable for any of this to work. So as these satellites are whipping around the Earth, they're constantly beaming down a radio signal. And that signal contains 2 super important bits of info. First, its own exact position in space. And second, the precise atomic clock perfect time that the signal was sent. Okay? You gotta remember those 2 things because they are the foundation for everything that comes next. Okay, so let's come back down to Earth now and talk about the second piece of this puzzle, which is probably the device you're holding in your hand right now. Yeah, your phone, your car's nav system, your smartwatch, these are all GPS receivers. And here's something a lot of people get wrong. They think these devices are sending a signal up to space, but that's not how it works. They don't send anything. They are completely passive. All they do is listen. They're just listening for those signals being beamed down from the satellites. So your phone is constantly scanning the sky, right? Listening for these signals. And here's where it gets really clever. Because each satellite is a different distance from you, their signals are going to arrive at slightly different times, and your receiver's entire job is to measure these tiny, tiny, infinitesimal differences in when each signal hits it. And that brings us to the real aha moment. So how do those tiny time differences turn into a dot on a map? Well, it all comes down to some surprisingly simple math. The big idea here is called trilateration. So your receiver knows the exact time a signal left the satellite and the exact time it arrived at your phone. And since we know that radio signals travel at the speed of light, which is a constant, it doesn't change, your phone can do a quick calculation. You know that old formula from school? Distance equals speed times time? That's all it is. So here's how it narrows things down. Imagine this. The signal from just one satellite basically tells your phone, hey, you're somewhere on the surface of this giant sphere. Okay, not super helpful. But then a second satellite signal comes in. Now you have 2 spheres, and where they overlap creates a perfect circle, getting warmer. Then a third satellite signal hits, that narrows the circle down to just 2 possible points. And this is why that 4th satellite is the magic number. It slams into just one of those 2 points, confirming your single, exact location on Earth. Boom. But wait, there's another absolutely critical reason for needing that 4th satellite. Think about it. We've been talking about those perfect, super expensive atomic clocks up in space. But what about the clock in your phone? I mean, it's good, but it's not that good. It has tiny, unavoidable errors. So that 4th signal acts like a fact checker. It lets your phone do a quick calculation, figure out its own timing error, and correct for it on the fly. And this is where it gets truly mind-bending. Without this correction, GPS would literally fail because of Einstein's theory of relativity. No joke. Those super-fast satellite clocks actually tick a tiny bit differently than ours down here on Earth. That 4th satellite allows your phone to sync everything up, correcting for its own imperfect clock and for the very fabric of space-time itself. It's this constant self-correction that takes the accuracy from just pretty good to pinpoint precise. So, when you put all of these pieces together,
The satellites, your phone listening in, all that math, you get something just incredible. You get the ability to pinpoint the entire planet.
And this whole process, it happens in milliseconds. It allows your device to figure out exactly where you are, anywhere on the surface of the Earth, down to an accuracy of just a few meters. I mean, that is absolutely remarkable when you stop and think about it. Of course, you've probably noticed it's not always perfect, right? Like when you're in a dense city with tons of tall buildings, the signals can get blocked or bounce around. They call this the urban canyon effect. And even the Earth's atmosphere can mess with the signal a little bit. So yeah, these are the real-world challenges that engineers are always working to solve. So the next time your phone tells you to turn left, just take a second and remember what's actually happening behind that screen. It's not magic at all. It's this incredible, beautiful dance between orbiting satellites, ultra-precise atomic clocks that even have to account for relativity, and a ton of complex math happening in milliseconds inside that little device in your pocket. It's truly a global marvel. You know, it's a technology we completely take for granted every single day, but the science behind it is it's mind-blowing, and it makes me wonder, what's the wildest or most remote place you've ever had to rely on GPS to find your way? I'd love to hear about it. Drop a comment below. Thanks for joining me for this one.